start the recording. I don't know what's up with the hissing, but oh well. This is Cuddly Jag. He's not usually super cuddly. He's gotten more cuddly like over the last 6 to 9 months, so you get a rare Cuddly Jag photo. Announcement. So very exciting talk that Philosophy is hosting this Friday. Professor Colin Allen from UC Santa Barbara, who is a philosopher of science and cognitive scientist and philosopher of cognitive science. He's going to be talking about, well, the title of his talk is Appearance or Reality, Does AI Need Emotions? And he's going to be talking about how and whether AI systems, which can include large language models, but also other sorts of systems, how and whether they can incorporate emotions, and whether this is important for like their social interactions with us. So I'm very intrigued to get more details about this. I don't know what his answer is going to be, yes or no, to the title question. That will be this Friday, March 14th, starting at 3:30. That will be in SSM 116, which is like the dance practice room in SSM. It was sort of the largest space that I could get because I'm hoping to get a bunch of people. I'm hoping we get good turnout both from the philosophy side, but also the cognitive science side as well.
I'm repping it very hard. I don't know if we'll get people, but I'm trying.
Okay. I mean, at least like a bunch of the faculty in CogSci are friends with him. So, yeah. Okay. So that's all I have in the way of announcements. There are like a few small fires I'm still dealing with in terms of finding arguments and getting the difficult conversation assignments turned in, but that's just like a handful of people. Are there any major issues? I haven't responded to all of the emails because I was out of town all weekend, but I'm working on it. Does anyone have any questions about class logistics? Okay. So last week we started talking about argument by example, aka generalization, aka induction. At the beginning of the week, we looked at enumerative induction, which is sort of the simplest way of trying to capture generalization in premise conclusion form. We looked at some problems with that at the end of the day on Tuesday. Then on Thursday, we looked at statistical induction, which is a more sophisticated way of trying to understand how a set of cases, observations, individual examples can be generalized to make claims about a whole population. In class, in lecture rather, on Thursday, we sort of ended up by starting to look at this little simulation I built of taking a survey. And I believe you continued that through the discussion sections on Friday, right? You spent a little bit more time and you spent some time actually playing with this and sort of talking about what you found as a result. So take a second. We're going to go slow today because everybody's tired. So take a second, try to remember what you did in in discussion on Friday. What was the upshot of these experiments? What did you find doing these experiments with the simulation? Try to remember. Key questions, basically how many of the simulations were within plus or minus 5%, or how small can the sample be and still get within plus or minus 5% about, say, 80% of the time. So try to refresh yourself on what you found on Friday, then check in with your table, and then we'll check in as a whole class. So a couple minutes for you to refresh yourselves on working with the simulation. So this probably involves looking at notes from last week. Well, if you don't have those, move straight to discussing with the members of your group about what happened. Do you want the birds back? Would the birds help? No, we're just exhausted. The logistics for coffee didn't work out, and then coming into campus this morning, it's like, oh, I could have gotten like a 20 bottle case, a 5-hour energy. Just straight up caffeine shots.
Probably a good thing I didn't bring coffee. I would have drunk way too much of it. On Tuesdays, my department have our tea times. I'll be having plenty of that. You've saved my health.
You're young. It's probably not as bad for you. I've not.
Yeah.
No.
You know what I've been meaning to suggest?
What's that?
Arizona iced tea.
Yeah, the logistics for me bringing in something that bulky is hard because I take my bike, right? I can't bring in 20 Arizona iced teas on my bike very
They
well.
have those big things that you could bring.
Like the cases.
The large bottles that you like pour into cups and stuff.
Well, then, to have enough of those for everybody. Yeah, that's the challenge. Okay, the hamsters are moving slowly as expected, but it seems like they are moving. So what did you find in this simulation? Playing around with the simulation on Friday, what did you find? Elizabeth.
Because I was kind of doing it in like smaller increments
Okay,
by 25 or by 20.
okay,
I feel like when you're doing it by that small of a change, you can't really see that much of a pattern. But when
Okay.
you go from like 200 to 150 or 200 to 100,
okay,
you can kind of see a bigger discrepancy.
okay. And what did you find 100 versus 200 versus maybe a larger sample?
When the sample got too large, it was definitely not as accurate to between those two bars. And then also when I did smaller numbers, it was more erratic, I guess. Like the number varied more.
Okay, yeah, so when the number gets too small, when the sample size is too small, the estimate gets more erratic. It can be way below, it can be way above. Sometimes it's pretty close, but it's less reliable. Okay, with a larger sample, you're generally going to get an estimate closer. More often, you will be closer to the true population value with a larger sample. Anyone think about sort of what size the sample should be? Let me rephrase. Do we need, say, 1,000 individuals in the sample to get a really good estimate? No, we don't. About what size sample do we need? A little louder? 100. About 100? Okay. Other folks? About 100? More? Less? Sahana?
I'd say like 300.
Maybe 300? Okay. So maybe 100, maybe 200, maybe 300. is this what you would consider a large sample? 100, 200, 300 observations. Elizabeth shaking her head, no? Depends? Depends on what?
Like what the subject matter is.
Okay.
Like if it's like for like a consensus that regards the entire world,
Uh-huh.
no, it's not. But if it's for a small town, then yeah, it would be a lot of people.
Okay. Devin, you were nodding?
I was just agreeing,
Okay.
like, if you're looking at like brain cancer stuff, 100 is a lot.
Okay.
Like if you're looking at patients.
Uh-huh. Okay. So, yeah, we often have the sort of intuition that if the population is really large, like the whole world or the whole United States, we need a really big sample for that. Whereas if the population is small, like people with brain cancer, or maybe we're talking about like students at UC Merced or something like that, if the population is smaller, we can get away with a smaller sample. That's actually not how sample size works out if you take statistics. If you take statistics, the sample size you need to get an accurate poll doesn't depend on the size of the population, which is very surprising to people. I think the other thing that is often surprising, and this is why I created this simulation, is that you can have pretty accurate results with what you think of as a small sample. So 100, 200, 300 people can be enough to get a pretty good estimate no matter how large the population is. In some sense, the population behind this simulation is infinitely large, because you can keep drawing people and get fresh people forever. So an infinitely large population, you can get a pretty good estimate with just a few hundred responses. So our ideas about what kind of sample size we need are often way off base. We think it depends on the size of the population when it doesn't. We think you need like 1,000 people or 2,000 people, even when you can get a pretty good estimate with just a couple of hundred. So the upshot here is that sample sizes can be smaller than you think. N equals 200. A sample size of 200 was actually pretty accurate. Even 100 did OK. If you look at a survey done by a professional surveying company or a professional opinion polling company, they usually go for 1,000 to 2,000 people. But that's because they're interested in getting accurate results for smaller subgroups, right? So they want to break out the results, maybe like Democrats and Republicans, or men versus women. Usually they don't take into account other genders, or relatively small racial and ethnic groups. So for example, Latina folks are about 19% of the US population. And so if you want to be sure that you have an accurate estimate for Latina folks, and you want, say, 250 respondents there, you need a total of over 1,000, depending on how exactly you're constructing your sample. So statistics has mathematical tools that can be used to estimate an appropriate sample size. But we don't have these tools in this class. This is not a stats class. We're not developing the math necessary to figure out what an appropriate sample size is or is not. So, as a rule, in this class, you're not allowed to criticize an argument by saying the sample is too small. If you say that on an assignment you turn in, that will be marked incorrect and you'll have to redo it. Okay? We're going to develop different ways, a different way of thinking about whether or not a sample is representative that isn't based on sample size. If you take a stats class and you get the background where you can use those tools from stats to think about the sample size, that's great. You can do that in the rest of your life. It's super useful. Not in this class, even if you've taken stats, because I don't know that you've taken stats. Devin.
Are we going to be referencing like confidence intervals at all?
Say again a little louder.
Are we going to be referencing confidence intervals at all in this?
No. Confidence intervals are cool. I like confidence intervals. That is way more math than we can get into. My approach here is concepts from statistics without any of the mathematical tools. Okay? So that even folks who never take stats can get some useful ways to think about statistical generalization. Okay. Any final questions on this illustration of how our intuitions about sample size are often off base? And consequently, in this class, you're not allowed to use sample size as a criticism. Okay, so let's move on now to rule 2 in this unit, which is to use representative samples. We're going to get a little more specific about what representative means, maybe today, more likely Thursday. For now, and the way we used it last Thursday when I introduced statistical induction, when we say that S is a representative sample of the target population X, that means S and X share all relevant properties, where relevant depends on the claim we're making at the end. Okay? So if we are assessing a statistical induction, one of the premises says that S is representative of X. And so we need to ask, do S and X share all of the relevant properties? So here's a couple of little exercises to do in your tables. Oh, actually, we need to do this first to generate the argument that you're going to work with. So, question. Should the city of Merced create an express bus line that runs between UC Merced's transit center, so right here on campus, to downtown Merced, 18th and M Street? That is sort of right near where it's not super close to like Coffee Bandits, but or Joystick, but like it's that area. What is it? Parliament? Is that the club down there? Partisan.
But I
That's
think
what
the K-18 is just right by the theater, right? Or the-
something like that. Yeah. Downtown Merced. The only place in town that has like entertainment venues. Okay. So the question is, should the city create an express bus line? That means no stops. You can get on at campus, you can go downtown. It'll take you like 15 minutes. When you're ready to come back to campus, you just get on, it takes you right back, and that will run until 2 a.m. So late at night. Everybody understand the question, the proposal? Okay. How many people would support this proposal, that the city creating this express bus line? Just raise your hands. Up high. I need to get a count. 2, 4, 6, 7? I think that's right. 7 out of 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Usually this is supported by a majority. I guess everybody is so tired. Okay. So 37% of Phil 4 students support creating this bus line. This is an interesting variation on how this usually goes. Okay. 37% of Phil 4 students support creating this bus line. Therefore, a minority of Merced residents support creating this bus line. I'm going to make this slightly easier. 37% of Merced residents support creating this bus line. Okay, So down here we have this argument, which as it turns out is against creating this bus line. Normally 4, but that's fine. So the exercise in your groups, first of all, to put this into premise conclusion form, I have the template over here on the right. So you just got that right there. You can make a copy of the slides and fill things in. So put this into premise conclusion form. Then there's another example here about sort of vaccine side effects as represented on social media. Take this one and put this one into premise conclusion form. And hopefully that won't take you too long. What we really care about is what's gone wrong in these two examples. So both of these are examples where the sample is not representative of the target population. So beyond putting this in premise conclusion form, I want you to think about why is this particular sample, in this case, not representative of the target population. Okay? So these 3 slides, 7, 8, and 9, put them in premise conclusion form, and then figure out why they're not representative, and remember that you can't say the sample is too small. Okay. Any questions about what I'd like you to do? Right. I will turn the birds back on, and we'll see where we are in 5 or 10 minutes. Or do you want my display and you don't actually edit anything? Do you want my display or do you want your own display? Was that to me? Okay. Okay, let's come back together real quick on this first one. What's the target population? Sahana?
Merced residents.
Good. How do you know?
It says Merced residents.
Yeah. So this is the conclusion right here. 37% of Merced residents support creating this bus line. We can actually start by just copying and pasting that. In this generalization, Merced residents is the grammatical subject. If it's been a long time since you did like the technical terms for English grammar, the subject is the thing that does the verb. So the Merced residents, that's the thing that does the verb, support creating this bus line. Okay? So in a generalization, the target population is usually the grammatical subject of the conclusion. So Merced residents. So we've got that. The target population is Merced residents. And then we need to know the sample, S. Devin? Yeah, you can just say fill 4 students. If you wanted to be a little more precise and you were a little more careful about putting the argument together than I was, it could be, the sample is 17 fill 4 students in class at a certain day and time. But this works for our purposes right now. So the sample is fill 4 students. Premise 3, we filled in those two parts. Fill 4 students is a representative sample from Merced residents. Tweak the wording just slightly. Fill 4 students is a representative sample of Merced residents. That claim doesn't work, but we're getting to it. We still need to fill in premise 4, the key statistic. This is what we observe about the sample S. So what is it that we observed about the sample? You think of the data. What's the data we have about the sample? I saw Jonathan's hand first.
Most of S does not support creating this bus line.
Not most. We can be more precise. 37%.
I wrote did not.
Oh, okay.
Not support.
So 63% of Fill 4 students do not support creating this bus line. That's fine. We would have to modify the conclusion accordingly. So it would have to be 63% of Merced residents do not support creating this bus line. That would be fine. I'm going to keep it at 37%. There we go. Good. So premise 1, the target population is Merced residents. Premise 2, the sample is Fill 4 students. Premise 3, Fill 4 students is a representative sample of Merced residents. Premise 4, 37% of Fill 4 students support creating this bus line. Therefore, 37% of Merced residents support creating this bus line. Okay. Any questions about putting this into premise conclusion form? Okay, so this is not a representative sample. There is a problem with premise 3. Premise 3 is not acceptable. Why not? Ayush.
We're college students,
You're college students, okay.
and
Uh-huh.
in philosophy class, so a lot of us are probably philosophy majors. Um, yeah, like it's a very, very specific and kind of different to the general person group of people represented in philosophy for.
Any other important features about you all? We'll go Devin and then Mike.
Well, kind of just adding on is because we're college students, we're not representative of all of UC, or not UC, just Merced residents.
Uh-huh.
Because there's many other walks of life. People could already be out of college working, or
Mm-hmm.
people could be in grade school or whatever. And so kind of just adding on where we don't represent all of those diverse positions.
Okay. Mike? Can I put that as more likely to be middle class? Is that kind of what you had in mind, Mike? Or, okay. Think Jack and then Nick.
People who like don't live near downtown or don't need to go to college have no reason for it.
Good. And then Nick.
Oh, that's basically what I was going to say.
Okay.
Even for anyone who doesn't go to UC instead of UC class.
Yeah. Okay. Good. Yeah, so these are all ways in which you all have very different properties as a group. You all have very different properties or a different mix of things like who works a full-time job, who is in the middle class, where you live. A common one is whether or not you have access to a car. So you as a group have a very different combination of those properties than Merced residents as a whole. And so that's why you are not a representative sample. Sort of the distribution of properties among you all is very different from the distribution among UC Merced, or among Merced residents. Questions or comments about that? Okay, so second example. I watched a video on YouTube about a girl who had seizures and trouble walking after getting a flu vaccine. It had 12 million views and hundreds of comments, mostly from people who had the same thing happen to them. Vaccines are dangerous. So same thing here, you're going to put this in premise conclusion form first. Note that the premise conclusion form is slightly more complicated than the other one. There's actually going to be like an additional conclusion you have to put at the end, a premise conclusion form here. But shouldn't be, think of it as just like a refresher on stuff we were doing last week. So put this into premise conclusion form. And then this is another non-representative sample. And so try to articulate why it's a non-representative sample. Any questions? Okay. Do you still want birds, or are you more awake now and you want maybe some music to help you wake up more? Or are you so tired you have no preference? Okay, we'll stick with birds. Okay, let's come back together. Where is the explicit conclusion in this argument? Specifically, yeah, the explicit conclusion is the last sentence, vaccines are dangerous. That is not one that easily fits into our template for all x's are y, or something like that. So that's why it has to be a separate conclusion. There's an implicit conclusion in terms that fits in the framework of statistical induction. We can either tackle this one first, the x, or we can either tackle this conclusion, or we can tackle premise 1, describing the target population. We can start either with 5 or with 1. Rephrasing the question, what is the target population? Sahana?
People who got the flu vaccine.
Good. Target population is people who got the flu vaccine. Okay. And then down here in number 5, I guess we can do this. People who got the flu vaccine. We know the statistical conclusion is going to say something about people who got the flu vaccine. Can we fill that in yet? Maybe not. Okay. How about the sample? Jonathan.
You could write the samples either one girl on YouTube or one girl on YouTube and hundreds of comments.
Good. So I think a lot of tables, as a first pass, said, well, the sample is one girl on YouTube, or the girl in the video. This runs into an immediate violation of Rule 1. What was Rule 1? All the way last week, 5 days ago. Jonathan? Yeah. Rule 1 says you need more than one example. So if this argument is meant to just have this one case as the whole sample, it wouldn't even get off the ground. We can do a better job giving more charitable read of this argument that doesn't violate Rule 1 if we have a larger sample. So what's the larger sample?
Would it be the hundreds of comments?
Mm-hmm. Honestly, the way I think about this, I just kind of ignore the girl in the video. I think of the sample as being just the hundreds of comments because, like, I have hundreds of comments over here, and like, okay, one additional girl isn't going to add that much. But we can include both of them. The important thing here really is the hundreds of comments, because those are the bulk of the observations that we have to work with. Okay? So the sample is one girl on YouTube and hundreds of comments. Any questions about that? Sample people who got the flu vaccine. So then we're just plugging things in. One girl on YouTube and hundreds of comments is a representative sample of people who got the flu vaccine. I think when you say it out loud, it starts to feel like, oh, this can't work. There's a problem here. We'll come back to what has gone wrong here in premise 3, but to write it out, it was just plugging in what we had for the target population and for the sample. Premise 4, the key statistic. This is a claim that's made about the sample. Deb?
Okay, I'm not sure if this is right, but
Yeah.
I think it's on the lines of most of the comments on the girl on YouTube got seizures and trouble walking with the vaccine.
Exactly. Most of the comments, commenters, and the girl suffered serious side effects from the flu vaccine, something along those lines. Now notice, we're paraphrasing pretty heavily. We've got mostly as the quantifier. We've got the commenters, we've got the girl. The argument has been kind of nonspecific about which side effects, right? The girl's side effects were seizures and trouble walking. The comments maybe were other serious side effects. So there's some work here with paraphrasing, and we would have to be careful in a real example. But what we have here, most of the commenters in the girl suffered serious side effects after receiving the flu vaccine. So this is the key statistic. It's not a number, but it's still, we still call it the key statistic because it's the claim that we observe in the sample. Questions about that? Okay, so now to go from the key statistic to the conclusion, remember we are basically copying and pasting, but with a find and replace. So rather than the sample, the commenters and the girl, we want to take that out and replace that with the target population, people who got the flu vaccine. So I basically did a find and replace, and then just check the syntax. Most people who, let's say, get the flu vaccine suffer serious side effects after receiving the flu vaccine. We can drop that part. So the conclusion, most people who get the flu vaccine suffer serious side effects, and therefore vaccines are dangerous. Questions about putting this in premise conclusion form? Okay, good. So now, under Rule 2, we're looking closely at premise 3. One girl on YouTube and hundreds of comments is a representative sample of people who got the flu vaccine. This is not an acceptable claim. This is not a representative sample. Why not? Ayush?
The video is most likely recommended to people who have already had negative experiences with vaccines or who have negative opinions of them.
Okay, so people who experienced side effects or have concerns more likely to see the video. Others? Oakley?
Not everybody uses YouTube, so you're not gonna get everybody's opinions, like people who've got vaccines in the past.
Okay. YouTube watchers, users. Just saying YouTube users are not representative. Well, the question here is, why is this not representative? So what is the way in which YouTube users probably look different from the general public? Do you have an idea there? Jalen?
I don't know what like how to describe that way, but I know the YouTube comments could just be like
Say a little.
they can just be lying,
Oh, they could just be lying.
lying or not miss. They're attributing the symptoms of something else to the flu vaccine.
Yeah, good. Okay, so that is, those are issues we're going to talk about more under the key statistic. Premise 4, the possibility that people are lying, the possibility that they are attributing these side effects to the vaccine when it was just something else going on. Yeah, those we're going to think about more as issues with sort of the way the key statistic gets measured and reported and so on, rather than whether the sample is representative. But those are good points. They're just going to go under a different heading. Elizabeth?
There could be comments of people saying that they never had any of those side effects, and those aren't taken into account. Or it's just not taking into account the thousands of people who never had any side effects. It's just focusing on
Yeah.
that.
I know that's something that Table 9 was talking about, especially Mike. Do you want to jump in on here, Mike?
The fact that people comment only on bad symptoms most of the time,
Mm-hmm.
bad circumstances that they have in their life,
Mm-hmm.
not always on the good ones. So if someone didn't have a problem with vaccines, or most likely not commenting on that type of video. But people who have bad experiences are already different that completely commented and affected that.
Yeah, good. So people who experienced side effects or have concerns about vaccines, not only are they more likely to see it because of the way YouTube's algorithm works, but they're also more likely to comment on it, right? To think that they had this bad experience because of the vaccine and then to comment on it. Jonathan?
There's a name for that effect. I forgot what it's called, but its primary example is sending out in mail a survey to a group of people about a policy. And the idea is that you're not going to get people who don't, like if it's just a policy that adds something but doesn't remove anything, you're not going to get answers from people who don't support the policy, because people who support it are going to read it and send back. People who don't aren't going to send anything back, they're just going to discard the mail.
Mm-hmm.
And so I forgot what it was. Basically, only a supporting party will respond if the unsupported party is unaffected by the poll or survey.
Yeah. Next week, we will have an example very, very similar to that, based off of campaign advertising for a ballot initiative from 2020. Yeah, good. Okay. Did we figure out how to fill in this one? YouTube watchers or users are not representative. Elizabeth?
One thing you could say is just generally, like social media might not be the right place to get scientific information, because generally people are a lot more inflamed and irritated online than they are in real life. So maybe polling people in real life would be a better.
Oh, interesting. Okay. So let's see. How do I want to, something about like social media tends to encourage like overly strong or overly confident statements, something like that. Rage bait. Okay. Yeah, good. Let's make this a little larger. Okay, that is probably good. Oh yeah, and we only have a couple minutes left, so I think this is a good place to end this. Good. So we've looked at these two arguments. We have put them into premise-conclusion form. Relatively straightforward in the case of the survey of you all. This example from social media and the way someone might try to use social media comments as evidence took a bit more work, but we were still able to put it into the template of a statistical induction. We talked about why these samples are not representative. Big differences between, on the one hand, the people in the sample versus the target population. Very different properties between the two groups. Now let's go back to the express bus line example. Let's say it seems pretty plausible that college students are more likely to wear hoodies. No. You all, UC Merced students, are more likely to wear UC Merced swag than residents of Merced in general. Can we agree that's pretty plausible? Okay, so that is potentially a difference between you and residents of Merced in general. Is that difference relevant to whether or not you support this bus line? No. So when we think about representativeness, whether the sample is representative of the population, we don't care about every difference that there might be between the sample and the target population. What we care about are differences that are relevant to the claim being made in the conclusion. So we don't care about, what kind of clothes you all wear versus what kind of clothes residents of Merced wear. We care about things like, do you have access to a car? Where do you live relative to downtown? How much reason do you have to go to campus versus downtown? How interested are you in being out until 2 a.m.? These are relevant differences to whether or not you would want an express bus line between campus and the closest thing Merced has to an entertainment district. Okay? So we don't care about all of the differences between the sample and the target population. We care about the ones that are relevant. So the phrase we're going to look into more next time is plausible relevant variation. So when we ask whether a sample is relevant, when we ask whether a sample is representative of the population, we are asking, does that sample cover all of the plausible relevant variation in the population? So that's where we'll pick up next time. Good work today. I hope everybody gets some caffeine and more sleep. Have a great rest of your Tuesday and a great Wednesday. And in the meantime, please write your 2-sentence paper.